Welcome to this second video on clustering and studying longitudinal data. So we ended the first video by constructing clusters of a transversal section of all the files. We took 10,000 events from every file, and then we clustered the T cells like something what we have here. We also made a UMAP of all cells where we can see our clusters again, and we made several heat maps that made us focus into the cells that we had an interest in. So now I'm going to go to the next notebook, and I need to clear everything. And so the notebook starts with a small explanation of what is it that we see, but I think I will skip that. So we see how the sizes of the clusters vary across the files. And this is going to take me a little while. So again, I load my tools and I ignore warnings. I construct one of my objects. And now I make a loop where I process the files one by one. So for each file, I take the events in that file, I add to it the events that we have already clustered, and then from the labeled events or the clustered events in this concatenated file, I deduce what are the best labels to give the rest of the events. And this is going to take too long for us to wait for, so I'm going to be back very soon because I paused the video. So 20 minutes later, it's done, and now I'm curious to see what has happened. It's a little bit exciting. Did we manage to get a nice separation, or is this just, I don't know, what am I doing here? Oh, I have changed my script, so now it's not called something like this. It's called something else. Yeah, so just a little small detail. And what do you think? I think that there's something that is red and something that is blue. So what is the difference? So the red ones, they have antibodies in the description, and the blue ones don't. So if I see differences between the days, maybe not. I don't know. That's a little harder. So it seems that no, it doesn't look like every second thing. But definitely we have seen that there are two groups. And that's kind of what was the thing that I took from the paper. And now we can ask, what are the clusters that do distinguish between antibodies and no antibodies? So then we can go back to the clustering we made and look at what were the clusters. It was, let's see, so we have some numbers here, 17, 20, 21, 22, 17, 20, and 21. So now we can go back and look where are they at the UMAP. 17 is hard to localize. 17 is this yellow green thing. I don't know where it is. I need my glasses. Maybe it's here. 20 is around here, so it's tiny, small. And 21 I see here. So on the UMAP it's kind of hard to find these tiny clusters. What about the heat map then? So this was not the one, this was not the one. Here we have 17, 20 and 21, and maybe we want to make a new heat map from 17 to 21. So we can look at just, oh, I need to see, it was not from 17 to 21, it was from 17 to 20. So there will be an extra cluster. Heat map tab. So now we have 17, 21 and 20 here. So one thing they have in common, there is some CD86 in them. And well, they're not quite CD4 positive. So that's a little strange. Maybe if we want to drill deeper into this, we want to make these clusters even smaller so that we distinguish between CD4 positive and not CD4 positives. So with smaller clusters, maybe we become more precise in what is distinguishing the different samples. But this must be for the next video. Otherwise, what do we have? We have this Li6C that is in 17 and 20. And in 21, we have a little bit of CD8. That shouldn't be there. But then there's no CD4. Aha! So that's okay then. We have this PD1, okay. And Tibet is kind of expressed all over the bench here. So maybe we can have a recap. How many cells is this? It's 1,000 cells out of 260,000. So it's less than half of the percent of the events that we're looking at here. Yeah. And 22, what is different from 22? It has less CD86, but still it has some, so maybe we should also cut that up so that we'll have smaller clusters with or without CD86. So we see that 22 does not distinguish, but 21 and 17 and 20 they do. And what do I have here? Here I just have something that I used to figure out what is the formula for this nice image that I showed you. And I can start talking about matrices and math, but I won't. I will only say that if I take a cluster and a file, then I can ask how many of the total events are both in that cluster and in that file. That gives me a table of numbers. And these numbers have been used to produce this image. But I have done something to the numbers. First I correct for the variation of sizes of the files, so that just because a file has many events doesn't make it more red. So that's the first thing I do, and then I kind of enhance the signal so that I emphasize the difference between. So in one column, in one cluster, I emphasize the difference between the different files, so that I get a color map that shows me something, that shows me what is the signal here. And I think this is a good note to end this video. I hope you like what you see, and I hope we'll have fun with this. If you want to go on with this, please contact me and we'll find a way. Either I'll find a way to share my script, or I'll find a way to help you analyze by making a service where you can use my script online. So, see you in the next video. Bye!